So, hi guys. So, in this lecture, we'll be seeing more of the examples of drawing isomers of a given compound. Okay, so let's start with this. We have C3H6. So, how many isomers are possible for this? One is this, and another is this way. If we calculate the dB, it will should come out to 1. Okay. For C4H8, the dB should come out to 1, so we can have either a ring, a simple chain. This should be the order. Total here should be 2, total here should be 5. If we have something like C4H6, the dB should come out to 2. As the dB is coming out to 2, dB is 2, so we can actually can have 2 double bonds or 1 triple bond as well. Triple bond can also be in the between the second and third. Double bond can be actually between the second and fourth, between second and first and third. Or we can have a ring and a double bond. We can have cyclopropyl ring, so cyclopropane ring with substituted double bond. We can have ring with internal double bond. We can have this also, and we can have a bicyclo compound as well, because the dB of this compound is 2 as the total number of structures you can calculate. Okay, we have C5H10. So I recommend that side by side watching the videos, you also make the structures along with me. Just pause the video, and after you are done making the structures of, let's say, this organic compound, then you can actually match with the ones which I am drawing, and can see which you missed out, and why you missed out. So in this case, I can see that you will face some difficulty in making this structure, because this is a bicyclic compound, and you would have a hard time thinking about you can also draw a bicyclic compound. But this type of questions do comes in JEE examination, and for most of you, I suppose you have made all these 5 plus 3 8, and you have ticked the option resembling the number 8, but the answer would be 9, and you will feel that which of the compound you have missed. But always remember that whenever dB is greater than or equal to 2, you must have a bicyclo compound in your mind. Your thought process should be like that. Okay, and you should not miss out on bicyclo compounds, otherwise your answer would be wrong. The correct answer is 9. Okay, so as soon as I'm writing this, pause the video, make all the isomers, then match with the correct answers which I am giving here. Okay, so what is the number of isomers for this compound? We can have, so you can see that the dB of this compound is easily 1. So let's make it out. 1, then 2, then 3, then 4, then 5, 6, 7. We can also have something like this, or this, or this. Okay, so this is the exhaustive list. Okay, let's talk about C4H8O. So the isomers for this would be this. Secondary alcohol with a propyl ring or propane ring. Alcohol in which a primary alcohol with a cyclopropane ring, and again a secondary alcohol with a cyclopropane ring. I hope you have calculated the dB initially in the compound, and that should come out to 1. So total number of isomers for C4H8O is 4. Now let's calculate for C4H10O. The dB should be 0. Primary alcohol should be something like secondary alcohol. You can have ether, metamers, secondary alcohols, with substituted or primary alcohols, then 3-member ring with secondary alcohol, or you can also have substituted methyl ring on one part of the ether group. Okay, so let's look at some more examples. I hope by now you are enjoying making all the different structures, and it would be fun and challenging part that are you able to draw all the possible isomers of a given compound or not, right? So I hope it's a fun activity and exercise for you, and it would take you a long way in getting your answers correct in all the JEE level competitions. So dB for this compound, I hope you have calculated dB first, and that should come out to be 1. So we can actually draw a double bond or a ring out of this compound. You can easily see that it is just about creativity and just drawing. And something like this also. So this is just for the four-member ring. You can actually draw for the 5-member ring or the 6-member ring, and I leave that exercise to you. So how do we arrive at the dB? 6 plus 1 minus h plus x minus n by 2. dB should come around 1. Okay, these are only 4-member rings, so you can draw the necessary else. This is for homework. So C4H6 ClBr. So this should come out to be, I hope you have calculated the dB, and that should come around 1. Is the dB 1? Why it's 1? There is only 6 hydrogens, so 6 by 2 should come around 3, and 4 plus 1 it's 5, so dB should come out to around 2. No, you are doing it completely wrong. There are 2 x or halogens also involved. So h plus x, which is 6 plus 2 by 2, which is 5 minus 4 equals to 1. 1 is the dB. Please pay attention in the calculation of dB when there are halogens attached. 1 can be this, or can be, okay. So let's draw the dB for isomers for this compound. So I hope you have calculated the dB, and I won't be repeating it. This can also have something like primary alcohol, or you can have something like O dash. Okay, can you have something like this? Something like this. Let's calculate the dB in this case. 1 is the ring, 2 3 4, and 1 2 3 4. 4 is the dB with the cyclic ring and 3 groups. And if you're not comfortable, we can actually count number of hydrogen atoms as well to satisfy ourselves. So in this, hydrogen atom attached to this carbon would be 3 4 5 6 7. Where is the 8th one? This is the 8th. Okay, and you can play around with this compound as well to calculate more number of such structures. Okay, so just an important note I want to make here is that for compounds having dBE of greater than equals to 2, consider making bicyclo compounds as isomers as well. Okay, so let us let us see that what is the nature of resonating structures. So this is slight off topic, but this will be used in the upcoming lectures. So the nature of resonating structures of aromatic compounds is also aromatic. So what that I mean is, means if you draw the resonating structures of aromatic compound, it would be aromatic only, because in a case it's not aromatic, then the resonating structure is not feasible. So I drop this question in your homework assignments, and you can actually found a contradiction on the statement and can report back. Okay, but I want you to think on this, and in the next lecture will be oh, before going on, I just forgot to mention an important exception as well, which I thought I will be telling you in this lecture. So an important exception is when we actually calculate the basic strength of certain nitrogen compounds in water and in air. So in water, what we have is, if we have a CS3 group attached to amine, so 2 degree is more basic than 1 degree, which in turn is more basic than 3 degree, and later comes the ammonia. Why? Because of stirring hindrances and some experimental nature, but we don't know exactly why this happens. This is some experimental facts, and this is the order. If we have C2H5 group attached to the amine, and this is in water, but in common we can say that, common or in gaseous form, better to put it as gaseous form, we can say that the nature would be 3 degree, 2 degree, 1 degree, and amine, obviously because 3 degree has more plus I effects attached to itself. Okay, this is in gaseous phase. Okay, so in the next lecture we'll be talking about geometrical isomerism, and see you in the next lecture. So till then, good luck and goodbye.